Alrighty, so hello folks. Today I spent a lot of time on the Web3 Matic, Solidity address, and honestly, quite excitingly, I think we have something that we can work with here. So to recap why we started this, so the Polygon network has gone live. FWEB3 has been sent there, and now a whole bunch of people have received, tokens there, or at least should have received tokens. Now we're on to the next problem, which is that because Polygon is a separate network and one that most of the community is probably not familiar with, they very likely don't have tokens. And because they don't have tokens, it's very likely that they are not going to be able to do anything there without first buying tokens or doing something else. And again, the point of this game overall is to make sure that that either if people are spending their own money, it's very limited. We could, in theory, ask everyone to go to Coinbase and buy tokens from Polygon, but quite honestly, what's the fun in that? The benefit of that network as opposed to like Ethereum is that gas is very, very cheap, and so giving away tokens isn't that big of a deal. So if you're not familiar with what I'm about to talk about, we decided that we're going to go and create a faucet. So what is a faucet? So Ethereum faucet testnet. Well, faucet looks something like this. So you'll get a website, and then you can put something in your testnet. Let's see, am I on the testnet? Nah, I'm not logged in, so I'm not going to do it. So what you'll get is some website or interface like this. You get to put in your Ethereum account here, and you can send me some 10 Ether. So it gives you some context here. It delivers, drips 0.3 Ether every 10 seconds. You can register your account in your queue, say blah, 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 a whole bunch of different details. And they show you how many, Ethereum is here. So that's the idea of a testnet. And what it allows you to do is be able to get tokens when you don't have any. In the old days, like on the Bitcoin network, for example, people used to be drip Bitcoin, where like they can go in there and get one Bitcoin basically from an address and things like that. That's not happening anymore. That's long gone. And even for like things like the Ethereum mainnet, it's become so expensive that basically virtually no one gets any tokens for the mainnet. Polygon did have some faucets for mainnet, for the main community, but the truth is most of those went out. So we decided, or I should say, I decided and a bunch of people in building decided was good too, is that we should create our own faucet contract to go and actually help people get Matic. And so what this would be is a smart contract deployed to the Polygon network contract, to be decided. And basically anyone who is a FWEB3 user and has tokens will basically be able to use this contract and use this website to be able to get free Matic. So this will be a tool for the FWEB3 community. If you have, tokens, we'll supply Matic through this, and only people who really own tokens on our net, in our account on the Polygon network will be allowed to be able to pull from this. So it's almost like a shared community resource that we're getting out there, and we'll fill the faucet. So this is how it would work. There will be some website where basically you'll log in and check. You'll click a button and say, here's my address, give me tokens. What it'll then do is we'll call a function that will then see where, a function called faucet, where then you'll be sent an address, and then you'll receive a predetermined amount of Matic. And we'll decide what all that's predetermined, we'll decide what that is later. After you call the faucet, you can use the faucet again after a certain amount of time. I said 24 hours, but currently right now it could be up to 60 minutes. None of this has been launched yet, but I'll show you how we've done this. And then after the time's elapsed, you can use the faucet again, to get some small amount of Matic, to do that. The idea is we'll put it out there. Anyone who's a FWEB3 holder and has a certain number of tokens, we're saying the minimum of 300 because that's what the airdrop is for. If you have that, you can use the faucet. You can pull tokens out, and that's real money. That's things you can do. It's not going to be a lot. Maybe 20 cents per pull, might be what we do, or something like that. But you can basically, you can just pull from that amount and do, what you wish. So, that's what we've decided to do. And now we have, we decide we're going to do this, and so the next step is how do we actually go about actually making this happen. So that's actually going to be the point of this video, just to show you what what I actually built. So to start, and you could have seen this yesterday if you're on it, I used a tool called, or a framework called Hardhat to go and make this this tool. And so if you search Hardhat Ethereum, you'll get to this website here. And honestly, I used a lot of these tutorials. So you can go into Hardhat, you can use this tutorial to go through and figure out what you're actually going to be doing, how to actually do this. It uses NPM, NVM, and a few other tools to really make this happen. But I found it to be really, really easy to use. I am not a serious JavaScript developer by any means. I'm actually a DevOps engineer by trade and know a little bit of analytics. So even though I'm not I call it an application developer by trade, this wasn't really that difficult. So you can go through it, and it gives you some tutorials on how to do this. I followed that and basically went through and did this, these contracts. So here's kind of how it got set up. So to give you an idea how, this is set up, what you do is you create a contract here, and you'll decide you have a contract. So I had to create two. One of them was this faucet contract, which is what we'll spend a lot of time on, and one of them was this test token. So this test token is really here to be in place of FWEB3. Because I don't have access to the tokens myself, I'm not on Polygon mainnet. I'm on my own local network that I'm using to develop. I had to go and create a token. So I created initial supply. I minted it based on whoever the sender is on this, which will just be the main account, and we'll go and that made it easy enough. Then I went and created this long contract here. And again, you can take a look at the GitHub address or the account if you're interested in seeing further, but you'll get to see piece by piece what we're actually doing. So you can do this on your own. You can go into Remix and create this, but really in order to really make use of this, you need to be able to interact with this and really test out these scripts. That's really where you need a lot of the help. And that's where Hardhat is just really, really powerful. So I'm going to go and right click here. I'm going to open up this, and I'm going to split right here. So here we go. So I'm going to split this over. So what I decided to do is I was going to take a test-driven development approach to actually making this. So test-driven development says that instead of going out and coding first, you basically code out what you want to do and say, I want my script to do X function first, and then I want to go and code out what it actually needs to do. So this is my deploy script. Let me go and get my test script. Split. Right, there we go. Okay. What I did was that I described, what I called the Schusterian test faucet. And this is, and actually, let's rename that Schuster Ether faucet. That's more descriptive. And what you do here is you basically interact with the contract as if it's in Solidity, as if you're in the console. So what I have here is I have the Ethers contract, which actually comes in Chai, that allows me to use Waffle and use their Hardhat's private testnet to go and test this out. But what I then do is I basically set up the function each time. So let's just take a look at one of these little functions and see what's going on. So I have this this test token here. And it's just code, so it needs to be deployed. So what you do, and what Hardhat likes you to do, is to say here is token awaits Ether's get contract factory and its Schuster test token. So we say, okay, we've already compiled this. Go out and get this contract and go and see where it is. And so it goes and gets the contract, and there's a whole bunch of other back-end things that it does to actually make it deployable and to get those features. So it goes out and gets those things and pulls them in. You then go and basically pull out the different signers. And so what this is doing is basically it's going out using Ethers, which again gets pulled in by this Chai and expect and all that, it's already pulled in when it starts running. So Ethers is already there. And it says get signers to go that. And these are a whole bunch of preset addresses. So Hardhat comes with its own blockchain effectively. You can think about it. It runs locally on my computer, and it comes with a whole bunch of addresses. So I called the first one owner, second one address, third one address 2, et cetera, and you can even get, put the rest of them into its own array to get signers, just so you have some things to play with. And then I, set up the token to say I want to deploy the token contract, and then I set up the faucet contract. So I said get contract factory, same thing, which grabbed this token contract over here, this one here, which I promise we'll get to that. And then I deploy it, but I deploy it with a variable called Schuster token address. Here's why Here's why this is so important. So we know this is not the real token. The real token has already been deployed by Sahil a week ago or 2 weeks ago, and is currently sitting on both Ethereum and Polygon to do that. So we know at some point like this is the token, but I'm on a local test network that isn't aware of that, contract. So what do you do? So what I'm doing is I'm kind of creating this test token as this, stand-in basically to say, okay, here's the token we're going to use. And what I do is in the construct, I create an address that is the token address and assign the token address to whatever I pass in. So I went and got the, Schuster token, I'm calling it, and basically got its address and saying, this is the token we're going to use for the rest of the variable. So this is where it gets set. And the reason before each is really cool is because now I've already deployed and set up the contract. And so for all these different describes below, the contract's already set up. So that means that in every single one of these cases, it effectively creates its own mini blockchain, runs a bunch of commands, goes and sees if it runs, and sees what happens. And the final thing I do is basically for address 1, I give it a whole bunch of, Schuster tokens basically, so that I can preset that. And that's going to make things a little bit more useful down the line. So now that we've set that up and I gave you a little idea here, we know the contract is deployed, but now we have to go and test out these different things. So I'll start with the end here. What you do is once you run all your tests and you have npx hard hat test, you go and enter, and then what hard hat's going to do is it's actually going to run the test suite. So it's opened up Ether test supply. It describes what the main thing is. So these are the faucet supply tests. These are the owner function tests, just to see which function's going to be done by E. And here's the faucet test, and this is the one that really matters. This is how are people going to get sent tokens? What's the variables to do that? How is that going to happen? And so far it's passing. We'll see if we can make some of those fail here, and let's see if we can actually do that. So let's start with a really simple one. So the first off, to say with the tokens apply, we want to make sure that, I have another before each in here. So I describe a function before each. I do all these things. So for every single test, this will exist. But then for the faucet supply, I make sure to put 100 Ether into it because I'm doing some test here. So the first thing I should say is to make sure that the faucet actually has 100 Ethereum. So I just put 100 in there, but we want to make sure that the fallback function is working correctly. That the transaction is going, is working as expected. So when you send a transaction, and so this is kind of interesting for your Solidity learning. So in the blockchain, the tokens, the native currency is kind of like a first-class citizen in the token. And what that means is that basically if you get an address or a smart contract or something, if you send it value, the Solidity and the contract knows what to do with that. It's the simplest function. It makes it really easy to use. But when you're doing a smart contract, you have to tell it what to do. So what I did here is that I didn't call a smart contract. I didn't call a function. I just sent a transaction to the faucet address with a certain amount of Ether. And so this is the owner address, and this is, defined up here. It has 100 tokens. And so when I call owner/send transaction, I'm basically saying the owner address and that unlocked private key. So there's a private key. So it knows the private key. It's totally unlocked. The system has control of it. It's sending a transaction to the faucet. And yes, I am definitely recording. Whew. You're sending a transaction to the faucet address, and then you're sending 100 Ether along the way, to do that. Well, here, there's nothing like a receive function or anything, but I actually got something better than that. So down at the bottom, I have a fallback function that are both external payable. So I have fallback and receive, and I'm not sure if both those are needed. It said it was recommended, but basically what this is saying is that, hey, if you can't match a function and you're not sure, and I call something that says this, you're going to fall back on this function and do this. So what effectively is happening is once I send the transaction, it doesn't know what to do that, so it says do nothing. But if you just have an external payable with a variable, or as with one of these receives, it's just going to take it and store that value. So even though I don't have a function that specifically says, oh, put money into the account, even though that's not defined, it is sending it and it's taking it in. So as you see here, my very first contract pass, for example, should have 100 Ethereum. I run the initial balance, await faucet get balance, which I do have to do. I do, maybe there's a way to get the function, but I didn't see it. So like, this is where it might get good. So function, get balance, view external returns, UN56, address.this.balance. So we see that. So let's go and make it fail. Let's make this one fail. So let's say, for example, let's send 10. Let's say that. And it parses those ethers. Let's see what happens here. And there you go. So in this particular case, it expected this lawn value, but it actually got this. So that's not one you're likely to do. This is already set up, but here is something that you are likely to see and do, because I made this mistake originally. So I had to put this ethers, utils, parse ethers, but let's not make that happen. Let's do this. Let's say value equals ethers.utils.parse. Oh, actually, let's just send 100. Let's say I forgot and said, oh, I want to send 100 tokens. 100 tokens will do this. And we'll send this value. Now let's run it again. And let's see what happens. And let's see. Oh, because I forgot a comma there. Let's go and send it again and see what happens. Get contract. Before each hook. So, okay, so I am missing something. So faucet. Ethers.utils.parse ethers 100. Let's see. Well, what if I delete this, I just do it like this. Maybe it's because there's no parentheses around it. Let's check and see. 100. Let's see if that works. Should in theory. Yep, there we go. So take a look. Before each hook for these brief or async, cost awaited owner transaction. Invalid hexify value. So, okay, so I'm gathering this is doing some sort of hex value. So, like, okay, so maybe you wouldn't do this. So if I did OXFF, let's just see. That's hexified. So maybe that's what what it means it's taking. Let's see if it does that. Yep, there you go. See? Because it's actually, let's see if I can get this right there. There, see? Here's the hex value it was expecting. Here's the hex value it got. So I sent it 255. It was expecting this monstrous number. So it was actually expecting a hex value. And what ethers utils does is it parses that ether and does all that work for you. So if you tried to put in 100, it wouldn't work anyway to do that. But it's expecting there. So that's the first thing we're really expecting. Then it should increase if another person's sending tokens. So I sent 100 tokens, but then I asked address 100 to send tokens as well. And it's doing the same thing. It's send parse ethers, and it's getting the old balance, checking with the new balance, and we're saying we're expecting new balance to equal initial balance dot add. So if you try to do plus in this context, it concatenates. So that's something else I've noticed about hard hat, where you have to use a lot of language like this, where you just can't do add and subtraction like you would expect. Instead, you have to do like dot add, dot subtract, and that gets it out there. So maybe there's a way you can use regular math for this, but it's safer to do this, makes it very clear. So that's the first thing. So next thing here, let's talk about what the owner function actually does. Actually, at this point, let's actually talk about the variables that go into what makes this function. So I've talked about a little bit about the supply. Now let's talk about how this is set up. So when you do a contract, and I call this Schuster Ether Faucet, it is ownable. What that means is that I'm going into Open Zeppelin, which is what I've already downloaded. I'm getting the ownable contract, and the ownable contract gives me some additional features on top of my contract to allow it to be easier to own. So, or to do additional features. So in this particular case, I want to say there is an owner of this contract. That owner is the sender, and that allows me to use some additional modifiers. One of those modifiers is only ownable, that only owner. So what this is saying is that if I deploy this contract onto a test net or elsewhere, I end up becoming the owner, and and if I put this little modifier on it, it means only I can go and do this. So why would you want that to happen? So let's say, for example, I know that I want to change some things on this contract in the future. Like this constructor basically is set up so that, it just runs the first time and makes things, easy to do. So the first time we set the token address, and we don't allow any resetting. It's private, so you can't get access to it outside anyway. You have the faucet drip amount in Ether or native token, because if this is on Ethereum or Polygon, it's going to send you one of whatever it is. So that isn't set up. But this timeout might change. And so this might be something where we go and say, all right, well, we decide we want to make this 60 minutes, to do that. But we find that too many people are pulling from it too quickly. So it's like, oh, we're losing a lot of money and other people aren't really getting time to use it. So maybe we want to go and change this. So I created a set timeout. So we have this set up in minutes to basically go to say 60 minutes to go and do that. And then we set a timeout to say, when we go and do, only the owner can do this. So here's what that actually looks like. So only owner can set the timeout. So here's the first one, the faucet.set timeout 20. So this is the other thing. When you first set up this faucet, and this took me a while to figure out, when you first set up this faucet and deploy it, the account that deploys it is the first account in the signers list. So by default, Hard Hat defines, or I'm not sure if it's Hard Hat or Ethers, whatever, defines that this owner is the deployer of this. So when I call faucets and I'm having the contract do stuff, it's doing so with the understanding that the person who's running this is the owner. So the owner is, the faucet, when you call faucet.set timeout, it is the owner saying, go set the timeout. What if we want to go somebody else and end up doing that? Or what if we want somebody else to inhabit that, to test functionality? Well, what you would do is use this faucet.connect. So we already have this contract. We're now connecting a new address. And again, this is another signer object that has been unlocked. So it's another unlocked account. And we have them set the timeout. Well, in that case, we know that's going to fail. So to do that, so if we go and look up here, let me make sure my tests have not failed yet. Great, should send funds, send ether, what yada yada. Should only allow owners to set timeout. Faucet.connect address 1.set timeout 20. So that means that it's set. So what if we ended up doing this as the owner? So the owner is setting the timeout, and let's say this timeout is something different, to do that. So what ends up happening if we end up making it the owner? Well, let's see what the test says. There we go. Should only allow the owner to set the timeout. So the transaction was not, reverted. So what it basically means that it passed when it shouldn't have. And we had to put this, so we have this await faucet, faucet set timeout to go and see if it's going to work. Then we have this expect faucet.connect address 1 set timeout to be reverted with. And this phrase here should be what's in the require statement. So if it's reverted and that is required, you can see here, let's see. Oh, it's not in this contract. That's why. This is what's in the documentation. I went to the ownable documentation to see that ownable caller is not the owner. So it's reverted. So that's working as expected. I may decide at some point to create some other like tokens. For example, the drip amount might change. That might be a good owner one to see what that amount is. You may do some other stuff like, you may want to decide like, to change the ERC20 minimum, if we decide that like maybe we don't want 300, maybe we only want 100 in the future. Those might be good to change, but at the same time, I don't feel comfortable taking too many of these things out. Because again, at the end of the day, this is financial software. You want as little controls as possible as needed. Like I can see timeout being one of those variables we would use to extend and contract to make sure that over time, we can control the amount of flow there to do that. But, even though we could change the faucet drip amount, even though pulling it out really doesn't cause that big of an issue, if we do fat finger something or we don't understand something about this contract, what might happen is somebody from outside of the contract, who isn't supposed to have access, maybe this only owner fails for some reason. It's unlikely, but let's say it does. All of a sudden, then you're giving them access to, pull down, the amount of faucet and, minimum. Certainly the thing you don't want them to change is this. That'd be the biggest one, because that means that they don't even have to be an owner to really, do that. And you're trying to stop somebody from draining the account. So that's, I'm not, that's why I pulled this one out, because I figured I want to change this, but I'm not sure if I want to change the other ones. But again, this hasn't been set up yet. So it's up to the future. Up to the community in the future, and, Sahil and anyone else who has interest in this, to see how many should be out there. So let's go through this, so that took you through the bulk of what most of these functions are, but we didn't get to the good stuff yet. That's really these two, the faucet and the has ERC20 token. And this is where I think it gets really interesting. So faucet also has the most checks. It's got 4 of them in here. I'm sure this could be expanded, but this is just kind of what I did over the day. So for the faucet, it should not send funds if there are no tokens to give. So that's really the first check here. You really should not, the first thing you should check is that if the funds are below a certain amount, it should really fail. And in that case, it's below the faucet drip amount. So up here, we have, a drip amount that says you're given a set amount. So when you go to a faucet, you don't get to choose how many tokens you get. You just get a set amount. So the fact is that if you have less than this amount, it's not going to give you anything. It should stop you from doing so. So what we do is we put this require statement, address.this.balance, which is the smart contracts balance, as we saw down here. And we're going to say the faucet drip amount needs to be above, the faucet drip amount. Otherwise, it's insufficient faucet funds. So in this particular case, we don't have, we haven't, preloaded this with Ethereum in this particular case. So or the native token, should not send funds there. So we expect to see, faucet address one address. So again, remember, because I'm calling from faucet, it's assuming the owner was connected, and that's the one who deployed. So that's what Ethers assumes is the thing that's, sending this. So faucet.faucet address one, address. It's to send into, so it's an insufficient token. So the next thing we do here is I send some Ethereum, so actually, wait, hold on. Let me go back. So insufficient faucet funds. And again, you can see it matches here. If that language isn't exact, and this is why I'm making a point of it, if that language isn't exact, hard hat throws an error. So let me show you what it means. Let's say I added a period, which is a pretty insignificant change at the end of the day. And I go and run the tests. Run the test, period. Assertion, expected transaction to refer insufficient faucet funds, but the other exception was thrown. Same thing. So you really should have the exact same font, exact same language. In that case, I copy and paste it, but I'm sure there's a better way to deploy this, maybe with environment variables or something. So anywho, now I go and run my tests, and then I send 0.5 ether, which is less than the total amount, which is less than the faucet drip amount. So I do ethers utils parse 0.5, and I run the same thing, and it should get the same error. Because I'm actually going and, I only have 0.5. So before it had 0, the faucet had 0. Now it has 0.5, which is still less, so it should still fail. Then finally, I send 0.5, which gets it to the exact 1, and then await the faucet, which will be a success, and then it goes and runs just fine. So we'll run the test again to make sure that it goes through. There we go, runs great. The next one says that, it should send 1 ether to a person who asks. So we take a look at this. We have a transaction hash where we're now filling the faucet with 100 ether. So it has enough to go through. We go and start to figure out what the initial balance of address 1 is to see how much it has. So it starts off in hard hat with about 10,000 Ethereum, which, so we figure out what the balance is to start. We await the faucet to see if it actually goes and is allowed some Ethereum. We now get the, address 1 new balance. We await address 1, get balance. So that's just checking the balance again. And then we go and see address 1 new balance is equal to the old balance plus 1 Ethereum. And we do this parse ether statement. And of course, this one passes because we actually do send 1. But there are two special functions about this, because this is pretty basic. This is just saying, does it send tokens? And the answer should be yes. But there's really two important things that need to happen here. One is that you shouldn't be able to pull from this faucet over and over and over and over again. You should not be able to do that. So it means we need to have some sort of timeout. So that's where this mapping comes in. These mappings are pretty cool because they act as a hash function, because you basically say you have a map for an address that goes to uint, and do that. And I define that I can plug in an address, kind of like an array. I can plug in an address and I go and get a number back out. Except that as opposed to an array is kind of a set length versus a mapping is just a hash that can go on forever, basically. Once you initialize a mapping, it kind of always defaults to false. Or false-y, we might be, a false-ish number. So in this particular case, like my owner address would, have, that's never gone through, it would be false, everything would be false. As soon as I use the transaction though, I go and set this, this number to be something, and I'll explain how that works in a minute. But really, this is the majority way you'll see people creating kind of like array-like objects, is address and uint, and it's very space efficient. Just because if it doesn't store anything, it means it automatically comes out false. So, should not send ether in timeout here. So in our token, we have a timeout set of 60 minutes basically to go through. So we're saying that, after 60 minutes we do that. So the first thing I do, because when I originally wrote this test, it was for 24 hours. The timeout has now been sent to 1440, which is how many minutes are in a day. So 24 hours. So the very first thing I do is I go and use faucet.faucet, and it gets a success. Then I do it immediately afterwards, and it's met with a failure. The reason it's met with a failure is because of this function right here. So let's go through this real quick. The very first time address 1 pays, it goes through this require statement. The faucet has 100 tokens. So there are, it's greater than the faucet dripping out, which is 1. Passes. So we move on to the next step. The timeout to 2 is less than blocktime.timestamp minus the timeout multiplied by 1 minute. So this is how you set minutes in doing this. And so originally I set this account up here to be, it originally looked like 60 minutes, right? But that math was very hard to deal with, and it was hard to manipulate that object with variables. And the Solidity says you can't do that. So instead, I did a timeout, and then once you multiply by minutes, it does the same thing. It turns whatever the timeout is to a minute. So in this particular case, the timeout is 1440 multiplied by minutes, and then I subtract that from the block timestamp. The block timestamp is a Unix timestamp, which is, it's like the number of seconds since January 1st, 1970 at midnight or something like that. And that's a pretty standard way to do, that is a very standard way to do time. So what you end up doing then is you get a block.timestamp minus the particular timeout times this is less than or equal to the 2. So the first time around, this is going to be 0. So this comes back, so the address payable, which is the account that's asking for, in this case, address 1, goes in, it returns 0. 0 is clearly less than the timestamp. So that passes. And then we're not going to focus on this one here if they have enough ERC20, because we test that next, so we'll go through. So very first thing you do is you do a timeout.2 equals the block.timestamp. So what we do is we figure out the current timestamp of the block and now say this address is equal to this timestamp. What we're effectively saying is this is the last time this address got a faucet. This is the last time this this address used this faucet, and we're just marking that down here. We then do this call function, which is like transfer. This is the safe way now to do transfer for some complicated reasons that really aren't getting into right now. But this is now how you send an amount. So we do the to address, which is address 1. We're going to call this function, which is to send value to the faucet drip amount and do this. And we're going to see if it succeeded or not. So this is kind of standard Solidity code now. I didn't choose this. This is what the language said. And so let's see. Let me go and save my contract here. Oh, what changed? We'll figure it out later. And we're going to send it a certain amount. And that's going to come from the smart contract itself. If it fails, it'll say fail to send. That's only if there's a network issue. We won't interact with that. And then we do this emission, which we're not really going to talk about right now. So when we go and send that, we get money the first time, it fails the second time, and then what we've done here is that we simulated a time increase on the network. We basically said that we're going to increase the time, because again, we're not going to let this wait 12 hours, to do another test. So we're going to simulate it by increasing the time by 12 hours itself. So 360 seconds multiplied by 12 hours gets you the time. So then we do off faucet again, still less than 24 hours, which is again, we defined up here. That needs to be 24 hours because that's 24 hours in minutes. And then we do one more time to say this and say 3600 multiplied by 12 and do that. So let's say we failed. What would happen? So let's set the timeout here to be 1 minute and see what happens here. And it fails because it did not revert. Why? Because it was 1 minute. It was 1440, but now it was a minute. So it meant that this one succeeded, this one failed, but then after 12 hours, it could succeed again and then went through. So this is a useful way to basically set the timeout and be able to change that. So for testing purposes, that worked. So that means that if you use this function here, because the second time you go through, you'll see the address, faucet still completed, but now it checks this timeout and it says, oh, it's no longer 0, it's some function. So we take a look at the current block timestamp of what the block is, subtract out how much time has passed. In this case, it was 12 hours. And we see, which is the timeout, which is 24 hours. 12 hours passed. So since this block, 12 hours has passed, but that's still not 24 hours in the future. So it subtracts that out. So even though this is not the way I would personally prefer to have this, because of the nature of how hashes work and, it starts at 0, this is the most efficient way to build that out. So it fails at this particular step. So that gets us through all of the main functions here, most of the requirements. It gets us to the faucet, but this is only creating a faucet that anyone could use. If I deployed this with all this, it could be used by any old person on the network. But no. This is for the FWEB3 community. We don't want people who don't own tokens to actually use this. So that's how this token here gets created. Has ERC20 and actually this whole brand new function. That's the way this works. So let's start with, test-driven development. Let's start first with what we actually want this to do. So it should not send tokens if there is an insufficient ERC20 20 token amount. So first we send a hash, we fill up the address because we wanted to, have tokens, so we don't want to fail that first requirement. Then we want address 2 to have tokens. So why address 2 and not address 1? So I did a little bit of a sneaky thing up here. So I have owner, address 1, and address 2. Owner has all of the ERC20 tokens. It's the one that was deployed the contract originally. So when do that. So if you take a look at the mint contract here for the test token, we minted to the message that sender the initial supply. And remember who the sender is, it's the owner. So that owner has all 1 million tokens. It's effectively, the owner of all of them. So it's the person who gets to deploy it. But address 1 doesn't. It doesn't have any tokens. So up here, what I did was that I gave it 300 tokens because I knew that was the minimum we were going to play with. And the reason why I was able then to use address 1 down here, like, for this token here when I tried to use the faucet, is that this requirement was held. You have enough tokens. So as you go up here, we have 300 tokens, which is, multiplied by 10 to the 18th because it's 18 decimal places. So that's the ERC20. It has 300 tokens. So address 1 was fine. So I know to use address 1 here. Address 2, though, doesn't have that luxury. It doesn't, it's not having it doesn't have any ERC20 tokens. So first we're going to call the faucet and it should fail and it should revert with this function here or this label. You do not have enough ERC20 tokens. And if you go over here, you do not have enough ERC20 tokens. Okay. So that's where it fails. So it it fails there, gives that callback so we know what requirement it failed at. Then we go and call a hash. And we go and say Schuster token.transfer. And again, this is like the owner transferring tokens. That's like me sending FWEB3 tokens to you guys. It transfers to address 100, 100 tokens basically to go and send that out. And it's basically sending 100 of the native token. So even though it's ethers.utils, because it's ERC20 and has 18 decimal places, which is the default for ERC20. Again, this wouldn't work if we change the number of decimals. So, I believe FWEB3 is 18 decimal places, but we can go and double check that. We sent 100. But again, 100 is less than 300. So we expect it to fail again because it doesn't have enough. So it's not enough for you to just have one or, a little bit. You need to have enough. So then finally we send a hash where the owner finally sends them enough tokens. They go and send it and it succeeds. So I mean, like if you went down here, change that to 100, run that test again. And it failed because it got an exception. You do not have enough ERC20 tokens. So we send over 200 and it goes and works. And there could be a third test where we send it 30,000 tokens, but I don't think that's really necessary in this case. So there's one additional thing that I think is interesting about this contract that I wanted to share with you folks. How did we actually get connected with that other token? And so that's where we finally get token address to come in here. And so this is in Solidity, which is a lot more stripped down than what I'm using in Hard Hat. So let's take a look. So require has ERC20 token to the to address. So the reason why we're using to here, as opposed to just saying, well, why not send in message.sender? Because message.sender is a perfectly fine way to, that's perfectly valid. It's just saying, hey, whoever's sending the transaction should go through and do that. Why wouldn't we use that? Well, the reason why is because when we're creating this Matic faucet, we're assuming the person who's asking for tokens doesn't have any. That's how all faucets assume. I mean, that's the thing. Why would you be asking for Matic tokens to play around with? Because it's not like there's going to be enough that you can get rich off of this. At most, if you mine this thing, you may be able to make a few bucks off of it in a day or so, maybe less. So the incentive is not to make you a lot of money. The incentive is to give you enough to play around with, and we want to limit it to the FWEB3 community. But what we're trying to do here, but that's not the reason. So because you don't have it, it's assumed you don't do it. So we're actually going to have an intermediary wallet. It's going to be a service. You don't have access to this, but it's going to be a hot wallet that has its own key. So there's actually going to be a second address that's available as the intermediary that when you click that button, it goes to a backend server that has that wallet and it will send your address on your behalf. When you put in that your address, the wallet in the middle is just going to take that to address and send it out there. If it was message.sender, I would actually be sending tokens to the intermediary, the message.send, the token in the center, and which is not what we want to do. We want this intermediary to send the tokens to you, that we end up using. So that's why we do this, we make it payable to as opposed to message.sender. Just a little background there. So has ERC20 tokens, and we're going to go to 2. And again, the reason I say that as well is because this originally was message.sender and it was giving me an error. And that's because we were checking the owner, not the actual to address. So that's a place where bugs can actually get introduced. We call in this function has ERC20 token from some particular user. It's private, so it can't be used outside of the function. We're only using this internally. It's view, it's not changing the state, and returns a true or false. So this require is looking for true or false. That's what this is doing up here. That's what this is doing all over here. So, if then true, false. We set up this special designation, which is an ERC20 instance, which is why we needed this Open Zeppelin import. And we go ERC20 token address. So here's where we're finally doing it. We're going out, we're finding this instance that we're saying, get me this ERC20 instance. And we're calling it instance. So if instance balance of user. So where we're going out and saying, here's this ERC20, which is on this network. Here's the balance of that particular user. If it is greater than the ERC token minimum, which is here, we're going to say true. That's okay. If else, it's going to return false. So when I ask the community to audit this contract, this is going to be one of the pieces of logic we really need to look at closely to make sure there's no issue. I've privated this function so it can't be called externally, to do that. So the only things that can call it are within this contract, and the only place it's being called is from here. And the only way you can get the to variable sent is from this faucet. There's no secondary way to be able to reach around and alter this. Because what I could do in theory, like let's say I fucked up this logic here. Let's say that that you could fudge that number, that it could send, that you could have it look at somebody else's wallet and say, pay to me, but look at this person's wallet, to do that, which is not that dissimilar from like the wormhole hack, right? This is not nearly as complicated as, like that, but it kind of illustrates the point that if those two were separate, I could go and say, pay to me, but look at his. So you could just point to Sahil's wallet and say, hey, do we have enough tokens? And it looks and says, oh yeah, you have more than 300. Now looking at, and then pay to me, that's a problem. Or if it pulled back and this value you were able to get a true out of this when it wasn't real. Like if you pulled out the user and was looking at the wrong place, that could have, you could technically pull out a true here. And even though you didn't have enough tokens, you got a true out of this. And then basically you would fudge the numbers. So, you would give the to address, block timestamp. So that's where there could be issues. So I pulled this out, I privated it, I turned it to view only. So none of the states can change. We have the ERC token minimum, which can't change, anywhere. We may give it to only owner, but we're gonna, we may debate that, on whether or not we want to change that in the future, and make that happen. So that's where the really strong logic, that's really what this hinders on. That's what makes this project unique. So not a lot of logic, only, a dozen lines or so to actually implement that, but it makes it something special for us. It's not, not anyone can come about, you have to have this, and this is a special utility for our community. And we can reuse this logic elsewhere to say, doing this. Like if I wanted to, and actually that might be a good idea. If I wanted to basically make this a modifier, I can make this its own function that we can say like only FWEB3, and we can basically go and say only people who are part of the FWEB3 community can go and use this. I won't institute that now, but that's an idea that we have if we want to maintain our own, smart contracts. So something else to consider. So anywho, that's really the nuts and bolts of what's going on here. So we have this contract. I've tested the whole thing. I am almost certain there can be more tests done here. Testing is a good thing. You can throw random shit at this stuff to see what actually fails versus not. It doesn't veer too far off the course from what a standard contract is. But again, this is really something that I want the community to look at, see if they can poke holes in it, etc. So that's what we've done. What can we do in the future? So this is the next step here. And of course, it's me, so I have a notion. So I will release this at some point for the FWEB3 Matic Faucet. I may release it tonight, actually, to go through. So what we're doing is we're moving the community to the Polygon network, and we need users to test this. So this is all ready to go out and be deployed. I actually have updated the hard hat config to actually go to the Polygon Mumbai network, which before we actually go and sent this off to the Mumbai network to do that, or on Polygon mainnet, we need to go and test it. So this network says that. So I'm going to create a deploy script. This is just a test deploy, so this is not, I'll have to rewrite that contract. But we'll deploy it to the Polygon Mumbai. I already have a MetaMask account set up where it has its private key. It's just for testing only, so like I'm not going to, this is not going to be going off, and I'm not using accounts that have real money in it. We have, I got a Alchemy account, which means that, we have our own RPC endpoint that we can use so that, I can actually process it and get it out there. We're giving it its accounts so that basically these 3 accounts are already set up with this so that we can, I can automatically deposit money and tokens into them and do some testing before we really get into the network, so I don't have any issues. I'm debating whether or not we need a Schuster test token in the Mumbai network. There's already a test ERC20. That means that has a faucet that you can go and get your own. So instead, I may just go and grab that address just so that we have something to play with. So anywho, the next steps are going to be, let's go and get the Solidity network up and running. Or let's get this running on Mumbai. Let's actually go and start testing it. I've already grabbed a whole bunch of names to go and see what's going on, and we'll see if it works. So we may actually do that one live. I just made this video just for fun to see what actually, went on. And yeah, that's really it. So anywho, thank you very much for paying attention to this. And yeah, I will talk to you all later.